Today we will be discussing different application of permutation, that is number of arrangements. Here we find number of arrangements of words, numbers, formation of numbers, or different kinds of placements, like how many ways the word computer, can be rearranged. So this question is regarding rearrangement of the word computer. What we are finding in the word computer, there are total 8 letters. 8 letters, all are different. So if I find the number of arrangements of the word computer, then we find that n, that is the number total, is 8, and the value r is also 8. So number of arrangements will be 8p8, which is factorial 8, and that is 40320. But we are not asking how many ways it is arranged, we are asking how many ways it is rearranged. The meaning of the idea rearrangement is, except the word computer, how many more arrangements are possible. That means we have to delete 1 from minus that 40320, that is 40320 minus 1 will be 40319 number of rearrangements. So number of rearrangements will be 40319 and number of arrangements is 40320. Now next question we can discuss how many ways a word of 3 letters can be formed from the word computer. So here I am not telling that all the letters of the word computer we will use, but we are now taking 3 letters. So how many ways word of 3 letters can be formed from the word computer? Here we are finding total number of letters is 8, but we are taking r as 3, so our answer will be 8p3, and which we can find 8 into 7 into 6, that is 336 different words. Now we are having some questions where we'll be putting some restrictions in the number of arrangements, like how many ways failure word can be arranged. How many ways the word failure can be arranged that it always include the word fail. So what I am seeing here, that how many ways the word failure can be arranged that it will always include the word fail. That means here we are taking fail as a single letter, as if it's a word, but we are considering this portion as a single letter, let it be X. Now other than this portion L, F-A-I-L, fail, this fail, if you separate, then you are getting 3 more letters present in the word failure. So our total possible letters are 4, and we are taking all 4 letters in the word, so it will be 4p4, that is factorial 4, and answer is 24. So failure word can be arranged such a way that the word will include the word fail in itself, so it will be 24 ways. But if I change the question, failure can be arranged that if AIL, that if A, I, L are always together, that means in this case I am not telling that the word fail will be inside the arrangements, but F, A, I, L, 4 letters are always together. So let it be F, comma, A, comma, I, comma, L, these 4 letters taken as X. And then we are having U, R, E, so total 4 different letters in this part, which is 4P4. But if you look at this portion, in this portion these 4 letters not specifically fail, it can be any other ways, and that will be also 4P4. And since both are arranged together means we see the rule and, that is multiply. So our answer will be 24 into 24, that is 576. So when we say anything, any concept as always together, then we take that portion as a single portion and arrange that letter or portion with other letters, and we arrange them. But if I discuss how many ways the word failure can be arranged, that F, A, I, L, again we are discussing the same way, are never together. So in the previous example we have discussed that these 4 letters are always together. Now we are going to discuss that they are not together, never together. So this idea of never together we can do this way, that total possibilities of all letters, we have total 7 letters. So total 7P7 ways, because if you count you will find that this 4 and this 3, 7 letters, that means the arrangement will be 7P7, which is 5040 factorial 7. 7P7 is factorial 7, which is 5040. And just now we have discussed F, A, I, L, these 4 letters always together means, just now we have discussed these 4 letters F, A, I, L always together means, we have discussed just now that 576. But in this question we are discussing never together. So we do one thing, that total possibility is 5040 minus 576. That means never together, whenever we require, we subtract the total possibility and always possibility, then we get the result as it will be, I think, 4464. Basically the idea of finding the result will be to get the total possible arrangement minus some objects always together. If you subtract, then those objects which are always together will be never together. So the answer, whenever the question is never, then we need to find out always. Now if I take an example like how many ways the word daughter can be arranged such that vowels are always placed at the odd places. That means in this word daughter we are having 8 letters. 8 letters means 8 places. So we are having 1st, 3rd, 5th and 7th places. 1st, 3rd, 5th and 7th places are odd places. That means 4 odd places. 4 odd places. Whereas there are 3 vowels, A, E, U. 3 vowels. So what you are finding, that 4 odd places, 3 vowels to be placed. That means we are finding 4P3 ways these vowels will be placed, because there are 4 odd places, 3 vowels. So we will be arranging these vowels in these 4 places in 4P3 ways. Now 5 letters are remaining which are consonants. because A, U, E, except that we are having 5 consonants. So 5 consonants and we are having 5 places remaining. So 5 consonants and 5 places remaining. That means 5 places for 5 consonants. Therefore, the result will be 5p5 for the consonants. So vowel consonants together we have total 2880 possibilities. Therefore, in this question we have found the number of arrangements of different words, and different words means with some restriction. The same type of questions can be given for persons to be placed, like 3 boys and 4 girls are sitting such that all boys are together. The first question, all boys are together. That means we are considering first question as boys are considered as one boy. That means one boy, because 3 boys are taken as only one boy because they are always together, one boy along with 4 girls. So 4 girls, 1 boy. How many ways they will be arranged? 5 total persons and 5p5 ways they will arrange. But these 3 boys can change their place. They can change their place in 3p3 ways. So what you are finding that 1 boy along with 4 girls, there are 4 girls and 1 boy because 3 boys are taken as 1. Together we have 120 into 6, that is 720 ways. So this is the first type of problem when we are finding that all boys are together. Now all boys are never together. The second part, all boys are never together. I have discussed just before that whenever we are considering never together, then what we can do, total possibilities of all 7 persons, total, because 3 plus 4, 7 persons to be seated 7p7 ways, that is 5040 ways. Now just now we have found that there are just now we have calculated all boys are together. That means all boys together, just now we have found that it will be 5p5 into 3p3, that is I think 3p3 is 6, and number of arrangements that vowels are now boys, sorry, not vowels, sorry, boys are never together. Number of arrangements that boys are never together. Boys are never together. This never together, boys are never together means total possibility 5040 minus 720 cases boys are always together. So it will be 5040 minus 720 and the result will be 4320. 4320 because you have to subtract, and that result will be the final result for how many ways they can be arranged. Now discussion can be continued with this question. Third one, no 2 boys are together. How many ways? No 2 boys are together. No 2 boys are together. So if you look at the example, 3 questions, no 2 boys are together and never together doesn't mean the same. No 2 boys are together means boys should be separated. No 2. No 2 means all the boys are separated. That means boys should be separated. Boys are separated. But in the case of never together, what we understand that all 3 boys are not together. Never together. That means 3 boys are not together. So what we have done, total possibility and always together we have subtracted. Now boys are separated. That means what we are having, 4 girls. 4 girls means if I write these girls, these are girls. Now 4 girls can be arranged in 4p4 ways. But what about the boys? 1, 2, 3, 4, 5 places we are getting where we can put one boy. That means this 4 positions, this 1, 2, 3, 4, 5 places are possible for 3 boys. So if I take them together and we get the result as 1440. So the difference between never together and no 2 boys are together will be to find out the arrangement of girls first, then take the gaps or places in between the girls, and we are finding from the beginning we are having 5 places in which 3 boys can be placed in 5p3 ways. So total arrangement will be 24 into 60 and the final result is 1440. Now one more point I would like to discuss, that is for linear arrangement today I am discussing, that is numbers. How many different numbers? This is the number cases. How many different numbers of 3 digits can be formed using 1, 2, 3, 4, 5. So it's a very simple case because 5 figures and 3 digits we are going to we are going to take 3 digits, but one problem is no digit should be repeated. This is a very important part of the problem. No digit should be repeated. This portion normally we consider in most of the general problems, that the digits are not going to be repeated. But it's not a mathematical or practical sense, but it's normally considered. If it is not mentioned, we consider that a repetition of the digits are not there. So what we see, n is 5 and r will be 3 because 3 digit number we are going to make. So it will be 5p3 and that is 5 into 4 into 3, that is 60. But if I add 1 0 in this question, then what would happen? I am changing the question. How many different numbers of 3 digit can be formed using, instead of this 1, 2, 3, 4, 5, I am putting a 0. So what is happening? Here 6 figures, but 3 digit we are going to take 3 digits, 3 figures for 3 digits. That means this is the possibility. First place is very important because if I put 0 at the first place, then the number will not be 3 digit number. So our idea will be never begin with 0. That means the idea will be to form the numbers, but 0 should not be at the beginning. So what will be the idea? Without putting 0 at the beginning, what we will be doing? 6p3 will be total possibility. Without considering where 0 is placed. Total 6p3 arrangement. But this number of arrangement may include 0 at the beginning. How many cases 0 at the beginning? If I put 0 at the beginning, no digit is repeated. Therefore, we are now having 5 figures remaining and 2 places are going to be filled up. So it will be 5p2, where beginning with 0 for these 3 digit number. So what we are finding, 6p3 cases, we are finding it is possible cases including or excluding 0 at the beginning. But 5p2 cases beginning with 0, therefore never begin with 0 we can find. (6p3) total case minus 5p2. 6p3 is 6 into 5 into 4 and 5p2 is 5 into 4. Therefore, we are getting 120 minus 20, that is 100. Therefore, we are having 120 cases minus 20 cases and the answer will be 100. in a simpler manner we can do. Perhaps many students will be preferring to do that way, that instead of doing this way, total possibility, counting the total number of possibility and then subtracting the possibility with beginning with 0, we can do the first place. If I consider the first place, then how many possibilities we are having? Instead of 0, we are having 5. So we are having 5, any figure can be placed at the first place because 0 is not to be considered. The next place, since the numbers are not repeated, the number what we have placed here will be not used here, so now it will be again 5. So 2 figures are used, the last place will be last figure, the last place will be 4. So if I take all possibilities, 5 into 5 into 4, it is also 100. The same answer will come. But this is somewhat shortcut. It is difficult to explain sometime, but it is easier to do. So that method we can do if you want to do in longer method, and it is shortcut. 5 into 5 into 4 will be total possibilities. Now we are going to discuss circular arrangements. If n different things are arranged in a circle, that is round manner, the number of arrangements will be n minus 1 factorial. This is because n objects, if you are arranging in a circle, then what you need to do, one object should be fixed, otherwise we cannot arrange the rest of the objects. So what we do, we take one less, that is n minus 1 objects to be arranged in n minus 1 places. One place is to be fixed with one object and the result will be n minus 1 factorial. That is the reason, that is the idea of circular arrangement. But in this case, if it is number of necklaces, which is also a circular concept, number of different necklaces, then we actually do the same idea, number of different necklaces using n different beads. This is also arrangement. N different beads are arranged in circle, then it is a necklace. So n different beads are arranged, arrangement will be n minus 1 factorial, but we are not finding the arrangement, we are finding number of different necklaces. We will be putting a half. That means the arrangement will be divided by 2 to get the number of necklaces. The reason is the arrangement of necklaces we can consider both way, round clockwise or anti-clockwise. So if I arrange clockwise and if I arrange anti-clockwise, number of arrangements will be different. But when we count the necklace, we will be not taking the necklaces arrangement, we take the number of necklaces, it will be divided by 2, any side we count. That means 5 persons are sitting in a round table, then 5 persons are sitting in a round table means 4 factorial, because there we will be fixing one of a person, that implies 5 minus 1 p minus or 4 factorial. So 24 ways 5 persons can be seated in round table. On the other hand, if I consider number of necklaces using like 10 beads, 10 beads are used for different beads, all are different, then we have half 10 minus 1 factorial number of necklaces, and the result will be 9 factorial divided by 2. Half into factorial 9 is 362880. Money means, what is the meaning of factorial 9? We know 1, 2, 3, 4 up to 9 we have multiplied, and dividing by 2 we are getting the final result is 181 divided by 181,440. That means total number of necklaces which can be formed using 10 beads, the final result we are finding 1,81,440. So that's all for permutation. More or less we have discussed different types of arrangements of different objects, both in linear and circular manner, and these are the problems which we generally face in different exams. So that's all for permutation applications.